Mechanical, electrical and environmental errors can be inadvertently included in measurement data if not removed by the calibration process. The spindle probe must be calibrated to minimize these errors. Once initial setup has been completed, the automatic calibration cycle can be run at intervals convenient to machining process requirements. One method for calibrating the spindle probe is to use a dial test indicator, a ring gauge, a tool of known length, and a ground engineer slip. Begin by securely mounting the ring gauge to a fixed position on the machine tool table. The true diameter should be known for the bore size. Next, the X and Y position of the center of the ring gauge must be determined. This can be found by setting the spindle roughly over the center of the ring gauge, then mounting the dial test indicator on the spindle nose. Adjust the dial test indicator so that when it's rotated by hand, it remains in contact with the ring gauge surface. Manually jog the machine to reduce the X and Y errors of the spindle center position in reference to the ring gauge. The error is seen on the dial test indicator. The error should be corrected to be as close to zero as possible, ideally within 5 microns. The X and Y machine encoder positions should be recorded at this point. To find the Z position of the top surface relative to the spindle nose, a comparator or tool of known length should be used. This is used because of machine spindle travel limitations. Measure it on the machine so that it's accurate for the particular spindle you're using. With the dial test indicator mounted on the ring gauge, jog the spindle nose in the Z-axis to make contact with the dial test indicator. Make a note of the machine position and dial test indicator reading. Now load the comparator or tool of known length into the spindle and jog it in the Z-axis to make contact with the dial test indicator. The difference in Z position equals the tool length. This value should be recorded. The spindle, loaded with the tool of known length, is now positioned close above the ring gauge surface. The slip gauge length is required at this point. The tool of known length is now jogged in Z- in small steps above the ring gauge. Slide the ground engineer's slip under the tool until it's been jogged too far. The tool should be wound back up again and the feed rate reduced, again using the jog and slide method. The jog and slide method is followed until the slip can no longer be moved under the tool at the lowest feed rate possible. The machine encoder position should be recorded at this point. The thickness of the slip gauge and the length of the comparator or tool of known length are added to the position recorded from the machine Z encoder. This gives the relative surface position of the ring gauge to the spindle nose or machine datum. Now the user has the precise X, Y bore position and Z surface height of the ring gauge to the machine datum. The spindle probe should be loaded into the spindle. The calibration cycle finds the trigger position of the stylus at various angles and axis directions. This removes many of the mechanical and electrical errors which would otherwise be included in the measurement data. To optimize measurement cycle time, the back-off distance can be adjusted in the macro program. Renishaw macro software includes an automatic calibration cycle to remove any errors from the stored position in X, Y and Z axes. The user calls the macro program, then positions the probe in X, Y and Z to the center of the ring gauge in the previously recorded positions. The stylus accurate ball diameter and the ring gauge diameter are now manually loaded into the calibration cycle. The calibration cycle is then run. Multiple angles of the ring gauge are measured. The ring gauge diameter is measured in the X and Y axes. Finally, the Z position is measured on the top of the ring gauge. You should run the calibration cycle periodically to ensure that any environmental changes are calibrated out of the probe measurement data.